Hello everyone, welcome to the next lecture on the testing of the hypothesis. Today we will discuss the one of the most important tests that is called as the chi-square test goodness of the fit. Myself Dr. Garg working in the School of Mathematics, Thapar Institute, Patiala. If you feel any doubt you can contact me by either of my email IDs are there or you can put them in comment on my YouTube channel. So what is the basic introduction about the chi-square? Firstly we need to understand what is the chi-square variate, the square of the standard normal variate. What is the meaning of the standard normal variate? All of you know that if my x follows, what is the meaning of that? This is follows. This n represent for my normal distribution. If x follows my normal distribution, whose mean is my mu, sigma square is nothing but my variance. So how you read this line is, if x follows the normal distribution whose mean is mu, variance is sigma square, then this quantity z is called as the standard normal variate, x minus mu by sigma. It always follows again the normal distribution with mean 0 and variance as a 1. So if this happens, then what is that? The square of this. So it means the square of the z. So chi square denoted by this is nothing but my square of this. So the square of this is called as the chi-square variate. And how many unknown variables are there? That is the x is the variable, so with 1 degree of freedom. On the other hand, if I just take as a xi, while I varies from 1 to n, having mean mu i's and the variance sigma square, then this quantity chi-square summation 1 to n have again a chi-square variate but with the n degree of freedom. So what is the density function of the chi-square distributions? As we know that if I assume chi-square as a random variable, which is nothing but the square of the standard variate, having nu as the degree of freedom, then this is called as the PDF, probability density function of the chi-square distribution. Definitely it is a continuous random variable and this gamma is represented for my gamma function. And if you calculate the mean, variance, mode and skewness of these chi-square distribution, you will get these values. And you are very surprising seeing that nothing but what is the relation between the variance and the mean variance is nothing but my twice of the mean. Also it satisfies the additive property. What is the additive property? Is the sum of the independent chi-variate is also the chi-variate. What is the meaning of that? If I assume that these are my independent, look at this word is important. If they are independent variate with degree of freedom n1, n2 and nk, then their sum chi1 square, chi2 square and up to k square is also a chi-variate with degree of freedom is sum of them. So that's the meaning is sum of the independent is also the chi-square variate. Now this is the most important thing is that the application of the chi-square distribution. So the chi-square test for the goodness of it, we will apply the chi-square test for the attributes and then solve it. So these are the four major important tests are there, and in this video we will cover this first test are there, and after that we will follow this series. So in this video we will see how the chi-square goodness of the fit test works for that. So why we study this goodness of the fit test? As we have seen in many day-to-day life problem that result obtained in the sample do not always occur exactly as of the theoretical result according to the probability rule. What is the meaning is that if you toss a coin 100 times, what do you expect that? We are expecting that the head is come 50 times, tail as a 50 times, because the probability of the head is half and probability of the tail is also be a half. So it means the mean is for the NP. Okay, so N is 100, P is half, so it will come to be a 50 and 50. But when you toss 100 times, it is very rare that these results occur exactly. So what is the meaning of that? It means there is some mismatch. There is some mismatch between the expected and the theoretical values are there. And this mismatch means this discrepancy between the theoretical, that is observed value, and the experimental value is measured with the help of this powerful test and called as the chi-square test of the goodness of fit. And this test is initially proposed by Carl Pearson in 1900 century. So what is the meaning of that? This test, chi-square test, is used to find the deviation of the experiment from the theory, and we will check that whether the results are deviates due to the chance, it's by chance, or is really due to the inadequacy of the theory. In order to do that, we will study firstly the what is the chi-square test. What is the meaning is that, so suppose we have some observed frequencies O1, O2 and On. Corresponding to this observed frequency, we will calculate. This is always our target. So we will denote it observed frequency as OI, expected frequency as a EI. Then the chi-square test is calculated by O minus E whole square and this, with the condition that the sum of this and sum of this both are same, and then the degree of freedom is n minus 1. What is the meaning of that if chi-square is 0? So since the role of this chi-square is to measure the discrepancy between the observed and the theoretical, if it is 0, it means there is no discrepancy between them. It means the results are exactly same. If chi-square is greater than 0, it means we do not agree that theoretical and the observed frequency are exactly same. While if it is greater than 0 and the number is very large, it means there is a greater discrepancy between the observed and the expected frequencies. So what are the conditions in order to apply this chi test? What are the conditions are there? The first one, it should be the independent. Second is the sum of the O is represent for my observed frequency, and observed frequency are always given to you, and this E is called as the expected frequency. Third one is the total frequency, that is this. The sum of this must be greater than 50, and no theoretical. Theoretical means that is a E. Okay, no, this E frequency should be less than of the 5. But what will happen if the frequency are less than 5? Then we will apply the chi-square test by pooled. So we will see in the example number 5 in this video. So since these, look at the assumptions are there. In this assumption there is no discuss about the populations. So that's why this chi-square test is also called as the non-parametric test or called as the distribution free test. So we will follow this simple 3-step rules are there. We will firstly define the null hypothesis. We will calculate the E and X square and then conclude the Z. How we calculate the E is, we will use this formula, capital N into P. P is my probability and capital N is my total frequency. So we will calculate this. So look at the first example is there. The number of the scooter accidents per month in a certain towns are given as this. So in the 10 months are there. So in the first month it is given at 12, second 8 and then so on. Are these frequencies in agreement with the belief that accident conditions were the same during the 10-month period? So we will apply the 3-step rule. Step 1, define the null hypothesis. So null hypotheses are always be here. Given frequencies, that is the number of the accidents per month, are consistent with the belief that accident conditions are same during the 10-month period. This is my H0. Now second step is you have to calculate the E and X square. What is the E? E always be N multiplied by P. P is the probability. So look at that, this is a 10-month period. So what is the probability of the 1-month period is 1 by 10. What is the N is? Sum of these frequencies. So look at that, if I just draw this and the sum of frequencies 100. So this is my E. Look at that. E is my 100 divided by 10. So now I can calculate E as 10 here. So under the null hypothesis, look at that. What is the null hypothesis? Is consistent means same. So that's why it is 1 by 10. So once we add here, this are. Now this is over. Now we will calculate chi-square by using this. We have this O. This O is always be called as the given frequencies or called as the observed frequency. E is called as the expected frequency. That is, we will calculate by using the formula NP. Now we need O minus E whole square. We will calculate O minus E whole square 4 minus 2 square 10 and then so on, and then we will divide. So this is my step number 2. Now we will calculate the step number 3. We will calculate the degree of freedom. Degree of freedom is N minus 1. Look at that 26.6. How many numbers are there which include 26.6? There are 10. So the degree of freedom is 9. So look at that, these are 9. So then you will draw the graph. The graph is always be the right tail. So the tabulated value of chi-square at 9 degree of freedom is, so you can see this value from the table. Look at that, we need the chi-square value at the 9 degree of freedom. Look at that, this is the chi-square distribution table. the value at 9 here at 0.05 is there. So look at the value is 16.92. So we will see 16.9 and this value is this one. Now we can compare this 26.6 with this, where it lies. It lies here. So it means this is lies in the rejected portion. So 26.6 lies here. So it means we will reject H naught. Since this value greater than, so it is significant and we reject the H0 at 5%. So it means H0 is rejected. So we conclude that are not uniform over the 10-month period. Look at the second example, it will clear more. A theory predicts that the proportion of the beings in the 4 groups A, B, C, D are in this. So this is a theory. Okay. In the experiment, among these 1600 beings, the number of the groups are this, this and this. Does the experiment results support the theory? It means the experiments get this results while the actuals are 9, 3, 3 and so are they believe they are same. So define the step 1 null hypothesis. Assume that there is no significant difference between the experimental and the theory. Calculate the E. So now look at that, E is my NP. What is the P is my probability. So look at that, probabilities are my 9, 3, 3, 1. What is the probability of the 9? So 9 by total. Probability of the 3, 3 by this. Probability of next 3. Okay, so now E can be calculated as N multiply P. What is the N is? Sum of group 82, 313 are given to you as this. Okay, so what is the N is? Total frequency. So now frequencies, probabilities are my here. So we will calculate E as this is my N into P. So this is the probability. So you will get. So you always get that the sum of O and sum of E are always be same. Now once you are here, you will calculate O minus E whole square. So this minus this whole square, this minus this whole square, and then so on. You will get this. So this is my chi-square. Now step number 3 is, what is the degree of freedom is? What is the step number 3? Degree, how many numbers are there in 4.76? These 4 numbers are there. So 4 minus 1, 3. Now you need the tabulated value at 3 degree of freedom. Look at that. This is a 3 at 0.05, 7.81. So this is the value at 7.81. Now you can draw the graph. This value is my 7.81. Now look at this value lies here. So what do you conclude that you will accept the H naught. So since this value lies this, so it is not significant. So hence the null hypothesis may be accepted and we may conclude that experimental results support the theory. This is the theory. Look at one more example is there. So there are some particular spare part in the factory and these are given. So test the hypothesis that the number of parts demanded does not depend upon the day of the week. So what is the null hypothesis is? The number of the parts does not depend upon the day of the week. Now step 2 is calculate E. E is N into P. N you can calculate as a sum. What is the probability is? So it is nothing is given. So the probability is 1 by how many days are there? 6. So the P is my 1 by 6. So look at that, these are there. So E is my N into P. What is the N is? Total of the this. So 6720. What is the how many days are there? 6. So this. So what is that? This is 1120. So these are my E. Again look at that, this must be same. O and must be the same. Now once you are here, you will calculate O minus E whole square. This is 4 into 16, 5 into this and so on. You will calculate this. So this is it. Now what is the step 3 is? You will calculate the degree of freedom. So look at that, this number, how many numbers are there? 6. So degree of freedom is N minus 1. So N minus 1 is 6 minus 1, 5. So you need the tabulated value 5 at 0.05. So look at that, this is 5, this is 0.05, 11.07. So this number is my 11 point. So look at that, where this value lies, it lies here. So it means this is accepted. So look at that. So we may accept the H naught. Hence we conclude that is same over the 6-day period. Look at one more example is there. A survey of the 800 families with the 4 children each reveals this. Is this result consistent with the hypothesis that male and females are equally probable? Okay, so now look at that, there are the male and females are there, so that is boys and girls. So firstly we will find the null hypothesis. So data are consistent with the hypothesis of the equal male and female. So then in order to find the E, we will find n into p. So we will consider either boy or girl. So I consider as a male. So probability of, since they are equal, so equal probability means half. Now, so in order to find this, we will use the binomial distribution. So what is the, how you find n into p is this. So this p is now for the binomial distribution. So what is the probability of the binomial distribution is ncx, p raised power x, q raised power n minus x. What is the n is 4, 4cx, p is half and so on. So you will get this. Now this is my p, so you will multiply this. So the expected value are n. Look at that, the value of n is 800 into this. Now substitute the value of the x. When x is 0, look at that, when x is 0, what is that? This 4c0, this is 1 by 6. 4c0 is 1, so this is 50. And similarly so on. Again the answer must be same. Now you have to calculate O minus E whole square, okay, and so on. So you will get this number. Okay. Now step third is the degree of freedom. How many numbers are there in order to utilize in this 19.63 is 5. Okay. So the degree of freedom is 5 minus 4. 1, 4. So the value of the chi-square at the 4 degree of freedom is my 9.46. So look at that, this is 9.46. So you can substitute here as this. So now look at the 19 point lies this side. So it means this is rejected H0. So it means this value is lies outside the domain. So we will reject H0. Hence male and females are not equally probable. Now in order to see in all these cases, what we have seen that the number of the frequencies in E are all greater than 5. Look at that, all the values are greater than 5. But what will happen if some of the frequencies are less than 5? Then we will use the pool test. We will see how it moves them. Look at that, while this is now in this case you have to fit the Poisson distribution. So what is the Poisson distribution is this. In order to find the Poisson distribution, the unknown parameter is only lambda. How you find lambda is, you all know that what is the lambda is, nothing but the mean. So how you find the mean? If you have the mistake, you have the frequency, you can calculate the mean. So the mean is fx by f. So this is the f, this is x, you can multiply, you can calculate mean. So this is nothing but by lambda. Now what is the task is fit the Poisson distribution and test for the goodness of fit. Now you can define the step 1. The Poisson distribution is the best fit. Now how you calculate the E is, again E is n into p, where this p is my nothing but my Poisson distribution. Okay, so this is my p, n is my total here. So you can substitute this value 1 by 1, x is 0, you will get this. Now you can't find O minus E whole square, because look at that, the value, always look in the value of the E. Nobody care about the O. Look at the value of E. We need all the values are greater than 5. Is it true? No. Look at that, these 4 values are not greater than 5. Okay. Now what you do is you can combine them. You can combine 1 by 1. If you combine 2, that is called as the pooled. Pooled means combine. Now you can combine, if you combine these two, are this value greater than 5? No. Then you can combine one more. Are these 3 values, if you combine, are this value greater than 5? No. Now again combine this one. If you combine these 4 values, are these values greater than 5? Yes. Its value is 5.1. Now it is greater than 5. So it means, now it means you have to combine this, and similarly for here, because they are 4 values, again you are here. Now look at that, all the values in the E are greater than 5. Now you can find the O minus E. This minus this, this minus this, this minus this here, and 15 minus 5.1 here. And after that you will get this one. So what is the value of the chi-square is 40.9. Now look at that, what is the degree of freedom? How many values are needed for finding this 40 point? These are 4. So look at that, degree of freedom is my 4 n minus 1, 4. Now what is the value of this one? Look at that. We have to fit this Poisson distribution. This is the case. We have calculated the expected value as here, and degree of freedom is n minus 1. So look at that, how many values are 4. So this is 4 minus 1. But you know, it is given to you that what is the value of the lambda? No, you have calculated this value of lambda by using this frequency. This frequency means you have calculated based on these frequencies. It means one time you have used this frequency, so that's why subtracting 1 here, because the only unknown parameter here is this is unknown to you, and you have calculated this value based on the given frequency. So this is the one unknown, that's why subtracting 1 more here. If you are trying to find the 2 unknown parameters, then we will subtract 2 at a time. So it means that correct degree of freedom is my 2. Now look at the correct degree of freedom 2 at 0.05 is 5.99. So this value is my this. Now compare 40 point where it lies. It lies outside the domain. So it means this is my rejected. So this value is greater than, so it is rejected. So we can say Poisson distribution is not the good fit. Look at the last example is there. A dice is thrown 60 times and test the level of significance if dice is unbiased. Unbiased means they are equally chance. So what is our step 1 is dice is on this. How you calculate n e is n multiply p. What is the n is sum of this. If the dice is unbiased, then the probability of the dice is 1 by 6. Dice is 1 by 6. So e can be calculated as what is the n is sum of this. So this is the 10. So it are all 10. Now you can calculate this O minus E whole square. Now look at that. Each value of the E are greater than 5. So you can simply calculate them. You will get 3.6. What is the step number 3 is degree of freedom. How many elements you needed to find 3.6 is 6 and minus 1 is 5. And the degree of freedom is 5. The tabulated value at 5 is 11.07. So the value is calculated as 11.07. Now you can see where 3.6 lies. It lies here, 0 to this. So it means we will accept the H0. So since this value is less than, so we may accept the H0. So we can conclude that the dice is unbiased. So this is the simple procedure you can follow for the chi-square goodness of the fit test. We will see in the next lecture for the independence of the attributes. So if still there is any doubt, you can put up any comments on my videos, or you can subscribe it, or you can put up email IDs. Till then, best of luck, students.